Okay, we're going to continue looking at radicals and rational exponents. And so, just a quick recap, if you want to cube a number, that is to the third power. And so, 2 to the third power is 2 times 2 times 2, which is 8. Now, if you want to undo the cube of a number, so if you want to find the cube root of 8, cube root, it's the cube root of 8. That's what the 3 in the radical symbol means. You're thinking what times itself gives me 8. And since 2 to the third equals 8, the cube root of 8 equals 2. Because 2 times 2 times 2 is 8. Okay, so you're going to go ahead and do exploration 1, and you can work on your own here. So it says use a cube root symbol to write the side length of each cube. Then find the cube root. Check your answer by multiplying. Which cube is largest? Which two cubes are the same size? Explain your reasoning. So we're saying the volume is 27 cubic feet. That is feet cubed. What you're looking for is the side length. So if you think of what times itself is 27, or the cube root of 27. I'll do the first one with you, and then I'll let you work on the rest of them. So the cube root of 27 is 3, and to check your answer by multiplying, 3 times 3 times 3, 3 times 3 is 9, times 3 is 27. So go ahead and do B through F, push pause, work on B through F, and then push play when you're ready to check your answers. Okay, you can go ahead and check your answers here, making sure that you found the correct cube roots. Don't forget your units. And move on to exploration 2. On exploration 2, it says estimate each positive nth root, then match each nth root with the points on the number line. Justify your answers. So you're going to tell me approximately what each of these equal. So now we want the fourth root of 25. So you're thinking, or estimating, really, what number times itself is about 25. And you will for sure want a calculator. Once you find those, match them up with A, B, C, D, E, or F. So push pause, do exploration 2, and push resume when you're ready. Okay, you can go ahead and take a look at the estimations up here. Yours should be about really close to that. I would say within a tenth at least. If you're looking for a strategy to estimate, take a number and put it to the power that the root is. So I saw, for example, A, 2 to the fourth was 16, and 3 to the fourth is 81, which tells me that the fourth root of 25 is in between 2 and 3, and it's 2.2. So A is about 2.2, B is about 0.7, C is about 1.2, D is about 4.0, E is about 3.8, and F is about 5.2. Okay, use those strategies. I'll go look at E here. I knew something to the 3 to the third power was 27, 4 to the third power was 64. 27 is too low, 64 is too high compared to 55, so it has to be 3 point something in between 3 and 4. Okay, now we're going to jump ahead and continue on what we looked at yesterday. So remember, if you're converting from radical form to rational exponent form, when we take radical form, you have the number inside the radical, and then you have an exponent. That is the same thing as the variable, with the exponent as the numerator and the number in the radical as the denominator. So it says rewrite the expression in radical form. So number 16, okay, we take the denominator, and that is the number that goes in the radical. So the fifth root of -3 is the number we're finding, and that is to the second power because the numerator is our exponent. Okay, for 17, 2 is the number in the radical. So it's the square root of 6, all to the third power. And really, remember when we do the square root, we don't have to put the 2 there. So I just say the square root of 6 to the third power. And it says express it in radical form. So we don't want to know what this equals. Okay, and lastly, number 18 here, I have the fourth root of 12 all to the third power. Okay, 19 through 24. Now you're going to evaluate. So we're actually going to figure out what things equal here. So first, you should probably change things into radical form because it makes it easier to work with. So 32 to the 2/5 power, that would be the fifth root of 32 squared. Okay, the fifth root of 32 is 2, because 2 to the 5th is 32. Then I need to bring down the exponent. 2 to the second power is 4. Negative 64 to the 3/2 power. So the square root, that is the denominator of negative 64 all to the third power. Okay, here, the square root of negative 64 is not possible because no number times itself gives us negative 64. If it were positive 64, then we could say it's 8. But in this case, there are no real roots. Okay, 21. So 343, you want the third or the cube root of that all to the second power. So the cube root of 343 is 7. Bring down the exponent squared, which equals 49. The eighth root of 256 to the 7th power. So 2 to the 8th is 256. So the 8th root of 256 is 2. Bring down the 7. And 2 to the 7th is 128. Number 23. Now notice, the negative is outside the parentheses. So that means take the 6th root of 729, multiply it by the 5th power, and throw the negative on at the end. The negative always comes at the end. So the 6th root of 729 is 3. Bring down the 5th power, put the negative out at the end. 3 to the 5th power is 243, and tack on the negative there, negative 243. Last one, the 4th root of negative 625 all to the 3rd power. Okay, now, finding the 4th root. So that's an even amount of multiplication. Okay, you cannot have a number times a number times a number times a number be a negative. It will never turn out negative. It's an even number that you're multiplying. It will always turn out positive. So in this case, this is not possible. So you say no real roots. And that concludes the rest of the lesson on radical and rational exponent form.